Hello folks, welcome back. I would like to take some time to just give you a little bit more of a flavor of what regression can help us understand here. So using a real life example. So what I have here is a plot of the domestic U.S. production of oil in thousands of barrels per day from 1850 up until 2019. So what you can see here is a very, let's say, different. It's an inconsistent graph. There's a lot of different patterns involved with it. Um, so we can see that it starts off very slow, very low, and then all of a sudden it starts increasing quite steadily for roughly 40 years, or even longer than that, and then all of a sudden it things change and starts dropping off, and all of a sudden it turns it right back around again into the present day here. So obviously, how would you go ahead and model this? Well, think about regression. Regression allows you to make predictions, but like any prediction, the model works only within a range of known known value points. It works best at that point here, and as long as the assumptions that undergird the model remain in force. So if you step beyond what you know, or if for some reason the environment changes, then the model that you have been working under for making predictions may no longer hold, and it's time to revise your model. And I think it's quite clear that when it comes to domestic oil production, there's definitely several different phases that we've gone through. And I like to express that in pictures here to better understand how regression can be used, or just understanding patterns in general can be used to understand what's happening when you look at a data set, because again, as things change, it's harder to understand how to make sense of it. So let's go with the first part. We're looking at this area here from the 1850 to about 1910. 1910 is the year that Standard Oil was broken up from antitrust legislation here. So I call this the Standard Oil era, from when it's basically how John D. Rockefeller made his money. So I tried to first did this with a linear regression, but you can see here that it doesn't really conform to a linear pattern. It's much more of an exponential pattern. So I fitted a trend line in here using the trend line tool, and it's actually, the first degree here is x to the 4. So this is a polynomial with the x to the 4th power gives us the main shape here. Now this expression does give us a very high r squared value. So this approximation, this equation does model this very well for, again, from 1860 up until, or 1850 up until basically the break of Standard Oil. So interesting plot that this is going to be exponential. And honestly, in any young industry, or oftentimes in startups, that's what it looks like. It starts exponential, and as things stabilize over time, then they move more into something a bit more linear and predictable in that respect. So we'll move on to the next stage of the oil production. Let's call this the boom years. And I will look at this. The scale here, 0 to 700. So you can see very small on the overall trend here. Now the scale gets a lot larger, from 0 up to 12,000. So when you do move from chart to chart, keeping an awareness of scale on each of the axes is important to really keep yourself focused on what's happening. So in this case, between 1910 and roughly 1970, for the most part, growth is generally linear, as a general rule. And in this case, Basically, every year we would expect to see output increase by 151,000 barrels per day, and that this relationship is a R squared of 97.5. So 97.5% of the data set has been explained by this linear relationship. Okay. Now, after 1970, we've had a lot of changes happening. The existing technology caused problems from us to actually extract oil. There are a whole other gamut of problems that I probably can't really explain very well because I'm not in that industry. But basically, after 1970, the oil production in the United States began to decline. So it fell precipitously for a couple of years, then got a little bit of a rebound a little bit. But essentially, up until 2008, it was on a steady decline, a linear 123,000 barrels of oil per day falling every year. And this is why by 2005 and 2007, there were a lot of articles saying peak oil, or because now we were producing less and less in our country, and now we probably are tapping the limits of what the world could provide us. So again, there was a lot of concern back in the late 2000s of peak oil, that how we were going to go into a managed decline, only because there was a way to satisfy our growing energy needs, particularly with emerging markets also requiring more oil production to suit their needs. So there was a real crisis about this. But lo and behold, technology through innovation has changed the game yet again. And now we are in the fracking renaissance. Now look here. The scale here is again from 0 to 12,000, same as the last chart. Now it's from 0 to 14,000 and only growing up. So here, now we can see this was going down 123,000 barrels a day. Now it is increasing 673,000 barrels a day. Wow, it's amazing growth from still linear. And you can see how, looking at the overall trend, this looks to be, it's definitely going at a very high rate relative to the others, but it's not obvious from this picture that it's maybe linear, but it actually is. But it's just the production capability is exploding at such a rate that it's really, really impressive. So over the course of only from 2008, so a little more than a decade, from 2008 to 2019, we've had more than a double of output within the United States in terms of production. That's really quite amazing. Now we don't know how long this is going to go. Maybe we might get close to reaching the end point of what this could happen. You have to understand that one of the elements of why we had managed decline is because we found our decline of domestic production is that we found cheaper sources of oil overseas, and it wasn't required for us to extract oil at a higher extraction amount here locally, because basically American workers are paid more, and the cost of fracking is still relatively high. But if we start, if all of a sudden the cost of extraction rises to the point where these more aggressive techniques are competitive, that's another reason why we're seeing a greater demand here locally for locally sourced oil, and as a result we're seeing an increase in net production because we're answering the market need. So I don't know if this has been helpful for you or not, but hopefully you realize that you can break down any large set of data into smaller chunks to make sense of it. Because if you try to fit a linear expression through this, you even try it, it's not going to be very good. So we'll add a trend line, we'll add the equation. So that's basically what it would look like here, but this equation linear would only explain about 90 or 79% of the variance across for the model. Not a very good model, and not terrible, but basically the other ways, by using shorter sections, can be much more informative of what's happening. So I hope this has been helpful. If you have any questions, you can just let me know. Otherwise, I will see you next time. Take care.